everyone. Today we are going to talk about the surface area of cones. So to start, please take a moment and solve the following on your own. Now hopefully you recognize with the bell ringer that you needed to use Pythagorean theorem to solve for the missing hypotenuse. So after square rooting, you should have gotten about 12.2 as your answer. Now, the reasons we talk about the surface area of pyramids and cones close to each other is because both of them have the common characteristic that they have a height, but they also have a slant height that's going to actually be used in calculating our surface areas. Okay, so notice, very similar to a pyramid, you have a lateral area. This is found by taking the pi times your radius length times your slant height length, and then you would add on to it the area of your base, which is pi r squared in the case of a cone, because the area of the base is always a circle, so pi r squared. Now, for number one, this is a great example of showing us kind of what we need each time in order to solve for the lateral area and surface area of our cones. So each time we basically need two things. What is the radius and what is the slant height? Now the radius here is given as 12. Slant height is given as 21. And the lateral area then is going to be pi times that radius value times the slant height. So pi times 12 times 21 is approximately 791.7 square feet. Now the total surface area then is going to take that 791.7 and add to it the area of the base, which again is a circle, pi r squared, for a total surface area of 1,244.1 square feet. So these are your two answers, lateral area, total surface area. Now number two is slightly different than number one because they give us the diameter. So in order to solve for the radius, we need to cut that in half. So our radius value is actually 6. Slant height is also given, so that's 10. So take a moment to calculate now the lateral area and surface area for this cone. Lateral area, you should have had pi times 6 times 10 for a total of 188.5 square inches. And then total surface area, you're going to add onto that 188.5 another pi r squared for a total of 301.6 square feet on that one. Now, number three is slightly different because notice they're giving us the height is 12. That is not the slant height. They are also giving us that the diameter is 10. So to start, they give us the diameter is 10. We know that we're truly looking for a radius of 5 in this problem. The other thing we need to be careful of again is that that is the height of 12, not necessarily the slant height. So what we need to do next is calculate our slant height by using, just like the bell ringer, Pythagorean theorem. Now, our height is 12. We also know that half of the diameter is that radius value of 5. So if we calculate now, L squared equals 12 squared plus 5 squared, we end up with L squared equals 169, and after we square root, L is found to be 13. So that slant height is 13. And now with the radius and the slant height, we can find our lateral area, which turns out to be 204.2 to calculate, and our total surface area, which is that 204.2 plus another pi r squared, the area base, for a total of 282.7 centimeters squared. Now, using those basic principles, we are going to start talking about some word problems. Now, for the first one, it says Ms. Minch sells frozen juice bars in a cone-shaped wrapper. The cone has a diameter of 6 centimeters and a height of 13 centimeters. What is the total surface area of the wrapper, including the lid? So just to give you a little bit better of a visual, imagine here's our frozen juice, and we are going to have a lid that we need to include on that as well. So total surface area is going to be the entire thing here, not just the lateral area, because you want the lid included. Now, a couple bits of information being given here. They give us the diameter is 6 centimeters, which means our radius is going to be 3. And they also gave us the height is 13. Again, that was the height, not the slant height. So before we can calculate any kind of surface area, we need to look at the fact that we don't have the slant height. We just have right now the height is 13 and the radius, half of that diameter, is 3. So we need to sidestep and calculate Pythagorean theorem, just like we did on that last part, because the hypotenuse, c squared, is going to be that slant height squared. So we have 3 squared plus 13 squared equals L squared. L squared is going to equal 178. And after we square root 178, we're going to get approximately 13.3 as the value of that slant height. And then again from there, our total surface area is going to be that lateral area, pi r L, plus pi r squared. So pi times the radius, which was 3, times the slant height, which is 13.3, plus pi times the radius squared, 3 squared. Type all of this in. We have pi times 3 times 13.3 plus, so there's our lateral area, pi times 3 squared for a total of 153.6 square centimeters worth of paper is going to be needed. Now our next example talks about Mrs. Helverson, and what Mrs. Helverson is doing is she's making a cone-shaped paper party hat for people at a party, and this is going to be for when we return to school. I know you all are ready for a big school reunion party. And the cones are 11 inches tall, have a base diameter of 7 inches, and we want to talk about how many square inches do we need for each hat. Well, unlike our snow cone example, think about a party hat, right? Here's one with a bunch of dogs, because dogs are my favorite. We have down here a party hat. Notice the bottom is open. There isn't anything on the bottom because it has to be able to fit on your head. So we're not actually looking for the total surface area in this particular problem. We're only actually going to look for the lateral area because, again, we don't need the base. So again, with lateral area or total surface area, we need the radius and we need the slant height. So notice they gave us the diameter is 7, which means the radius is half of that, so 3.5. The other piece they gave us is the fact that it is 11 inches tall, which means the height is 11, but we need the slant height. So when we calculate the slant height here, we know we are looking for L, and we have a height of 11, and this base here is 3.5 of our triangle. So slant height is going to be our c squared again, and 11 squared plus 3.5 squared. Well, 11 squared plus 3.5 squared is 133.25. And when you square root that value, your slant height ends up equaling 11.5. So again, the slant height is what we needed here, as well as the radius. So finally, our total lateral area, pi r is 3.5 times L, 11.5. If we approximate this in the calculator, we get about 126.4 square centimeters. All right, last but not least, imagine we have almost like a crayon here, right? We have a cylinder with a cone on top of it, and we want to find the total surface area. Well, similar to some of the problems we've done in the past, the total surface area of this composite figure, we need to take into consideration what can we actually touch. For instance, we can touch the lateral area of this cone, right? And we can touch the lateral area of this cylinder plus one base. This base inside of here, though, is being covered both the base of the cone, that's also one of the bases of the cylinder, so we don't need to include it. It's only one base that's going to be exposed as the surface area. And then our total area would be found by adding those two together. Well, the lateral area of this cone is going to be found by taking pi times the radius times the slant height. Well, the radius of both of these bases are the same, and that is 3. So pi times 3. And the slant height is also actually being given to us for the first time in a while. So we have a total lateral area here of about 47.1 square meters. And as we focus then on the cylinder then, reminder with a cylinder, the surface area, or in this case, the lateral area plus one of the bases, is going to be found by taking 2 pi RH, the lateral area, plus 1 pi r squared, because we only want one of the circular bases included. So again, the value of the radius, we said, is 3. And then the height here is in reference to the height of the cylinder, which is 10, plus pi times, again, that radius squared. We end up with a total surface area for this cylinder, and it's one base, of 216.8 meters squared. Now finally, to find the total area, we need to add together the lateral area of that cone plus the total area that we found for the cylinder for a final answer of 263.9 meters squared. All right, now for our closure question today, how do you determine when to use the lateral area and the total surface area formulas for a cone? Well, we use the total surface area when we want the surface area for the entire cone. So think about when you can touch the entire cone, aka the base is included. When we want total surface area of a cone, we want to include that base. Well, you only want the lateral area when we do not include the base. Okay. Thanks, everyone. Have a great rest of your day.